Far beyond the orbit of Neptune lies Pluto, one of the most mysterious worlds in our solar system. Once called the ninth planet, Pluto was later reclassified as a dwarf planet, but that only made it more fascinating. Covered in frozen nitrogen, methane ice, giant mountains, and strange heart-shaped plains, Pluto looks less like a dead icy rock and more like an active alien world hiding secrets in the darkness of deep space. Scientists still debate how Pluto formed and what may exist beneath its frozen surface. Some researchers believe it could hide a vast underground ocean beneath kilometers of ice. In 2015, NASA's New Horizons spacecraft shocked the world by revealing towering ice mountains, possible glaciers, mysterious atmospheric haze, and signs that Pluto may still be geologically active today. How can such a tiny, distant world still have activity after billions of years? And what other hidden mysteries remain frozen on the edge of our solar system? February 18th, 1930. Some kid with a telescope thinks he's found the ninth planet. Fast forward 76 years. Scientists boot it out of the Planet Club and call it dead. Then 2015 hits, and we get our first real look at this demoted world. Everything we thought we knew? Wrong. This isn't about some frozen wasteland. This is a murder mystery in space. And Pluto might be hiding an ocean containing as much water as all of Earth's seas combined. You're a detective now. The crime scene? A tiny world at the edge of nowhere, supposedly lifeless for billions of years. But the evidence doesn't add up. The surface looks brand new. Mountains are floating around like pool toys. There's mysterious blue smoke everywhere. And deep down in the ice, something's moving. How does a world smaller than our moon, colder than your worst nightmare, on average 40 times farther from the sun than we are, still have a pulse? Stick around for 30 minutes. We've got 4 pieces of evidence that'll mess with your head. By the end, you'll never think about our solar system the same way. First, let's paint the picture. Pluto sits in the cosmic equivalent of Siberia. It's 2,377 kilometers across. You could drop it inside the United States and have room left over. Temperature? Try negative 229 degrees Celsius. Cold enough to freeze your breath solid before it leaves your mouth. For 76 years, we called it the ninth planet. Then 2006 happened. Astronomers decided Pluto hadn't cleared its neighborhood. Basically, its orbit was too messy. People lost their minds. How dare you kick little Pluto out of the club? But here's the twist nobody talks about. Getting demoted was the best thing that ever happened to Pluto. Why? Because it made us actually look. Enter NASA's New Horizons spacecraft. 9.5 years, 3 billion miles. The plan was simple. Snap some photos of a boring ice ball and call it a day. Instead, the images that came back made grown scientists gasp out loud. Where they expected a crater-covered corpse, they found towering peaks, vast plains, and something that looked suspiciously like weather. Dr. Alan Stern, the guy running the show, said it best. Pluto has dumbfounded us. This world is alive. Alive? On a world where the sun looks like just another star, where water ice is harder than concrete, where the atmosphere makes the top of Mount Everest feel thick. That's exactly what we're here to figure out. 4 clues pointing to something impossible. Pluto isn't just active. It might be hiding the biggest ocean in the outer solar system. Sounds crazy? Good mysteries always do. When those first high-res images hit Earth, Scientists couldn't process what they were seeing. There, covering a quarter of Pluto's face, was a massive heart. They called it Tombaugh Regio. But the left side of that heart, Sputnik Planitia, was about to break every rule in the Planetary Geology Handbook. Picture a smooth plain 1,000 kilometers across. That's like driving from Chicago to New Orleans without hitting a single pothole. But here's the kicker. This enormous area is almost perfectly smooth. Zero impact craters. No ancient battle scars from billions of years of cosmic target practice. Most worlds wear their history on their sleeves. The moon's face is a roadmap of violence going back 4 billion years. Mars looks like it went 10 rounds with the universe. But Sputnik Planitia? Someone hit the reset button yesterday. In planetary terms, this surface is a newborn, less than 10 million years old. That's practically still wet behind the ears. Look closer, and it gets weirder. The whole surface is carved up into polygons, each one 16 to 48 kilometers across. These aren't random cracks. They're organized, geometric, like nature's been playing with a cosmic jigsaw puzzle. What you're seeing is convection, but not the kind you'd expect. This isn't molten rock bubbling up. This is nitrogen ice, frozen nitrogen gas, churning like the world's slowest lava lamp. Here's how it works. Warmer nitrogen ice rises from below, spreads out at the surface, cools down, then sinks back into the depths. Rinse and repeat for millions of years. It's like watching paint dry, if paint could erase meteor impacts. But wait, convection needs energy, heat. On Earth, lava lamps work because we plug them in. What's powering Pluto's cosmic lava lamp? The sun sure isn't doing it. At Pluto's distance, sunlight is 1,600 times weaker than on Earth. You'd need a magnifying glass the size of a football stadium just to melt an ice cube. The energy has to be coming from inside. That's clue number one, pointing towards something very unexpected happening deep beneath the surface. If the heart was surprising, the mountains around it were downright offensive to physics. New Horizons found peaks reaching 3.5 kilometers high, heights comparable to many peaks in the Rocky Mountains. They named them after the guys who climbed Everest: Hilary Montez, Tenzing Montez, Norgay Montez. But these aren't normal mountains. They're made of water ice. And at Pluto's temperatures, water ice doesn't mess around. It's as hard as granite. These peaks are basically carved from rock-solid ice. Here's where your brain starts hurting. These massive water ice mountains are sitting on top of nitrogen ice plains. But nitrogen ice is denser than water ice. It's like trying to float a bowling ball on honey. Physics says no. Yet somehow, these mountains are floating. They're bobbing around like icebergs in a frozen sea. The answer? Isostatic equilibrium. Same reason continents float on Earth's mantle. The mountains might be dense, but they're still lighter than what's underneath. So they float, constantly adjusting as the nitrogen ice below flows like cosmic molasses. But that's not even the strangest part. Scattered across Pluto are what can only be called volcanoes. Except they're not spewing lava. They're cryovolcanoes, ice volcanoes. Take Right Mons. It's a dome 150 kilometers across with a deep crater in the middle. If you saw this on Earth, you'd immediately think volcano. But instead of erupting molten rock, Right Mons probably erupted a slushy cocktail of water, ammonia, and other ices. Cryovolcanoes need two things: something to erupt and heat to keep it liquid. On a world that should be frozen solid all the way through, where's this coming from? As New Horizons flew away from Pluto, it looked back and caught something nobody expected. Pluto has a blue sky. Not just blue, a complex, layered blue haze reaching hundreds of kilometers up. This isn't Earth's blue sky. Our sky is blue because tiny air molecules scatter blue light. Pluto's atmosphere is way too thin for that. Instead, Pluto's blue comes from something much weirder. High up, solar radiation tears apart methane molecules. This kicks off a chemical chain reaction, creating tiny particles called tholins, basically organic soot. These particles are the perfect size to scatter blue light while letting other colors pass through. They form in the upper atmosphere, then drift down to the surface like cosmic snow over thousands of years. But here's the thing: this process devours methane. UV radiation constantly breaks down methane molecules. If there wasn't fresh methane coming from somewhere, the atmosphere would have been stripped clean billions of years ago. So where's the methane coming from? It can't be from the surface. Most of Pluto is too cold for methane ice to turn into gas. The methane must be coming from somewhere warmer, somewhere protected, somewhere underground. The atmosphere is sending us a message. There's active outgassing happening. Methane is somehow getting from inside Pluto to the surface to the sky. That means warm pockets exist inside this supposedly frozen world. Look at detailed maps of Pluto and you'll see something disturbing. The whole world is covered in scars. Not impact craters. These are different. These are cracks where the surface got pulled apart. Long, linear features stretching hundreds of kilometers. Some would make the Grand Canyon look like a scratch. But here's what's really telling. They're all extensional. No compression anywhere. What does this mean? Pluto has been expanding. At some point, possibly over billions of years, the entire world grew larger. The crust stretched until it cracked, creating the network of faults we see today. What could make a planet expand? Really, only one thing fits: a subsurface ocean slowly freezing over geological time. Here's the physics. When water freezes, it expands by 9%. If Pluto started with a liquid ocean beneath its surface, and that ocean gradually froze from outside in, the expanding ice would push outward on the crust. Over millions of years, this would crack the surface exactly like what we observe. But here's the kicker. If the ocean had completely frozen, we wouldn't see the active geology from our first three clues. The convection, the floating mountains, the cryovolcanoes, the outgassing. None of that works on a totally frozen world. Only one explanation fits all the evidence. Pluto still has a liquid ocean today. Connect the dots. Active surface geology, powered by internal heat. Cryovolcanoes, suggesting liquid stuff at depth. Atmospheric chemistry, requiring subsurface outgassing. Surface features showing long-term expansion from a freezing ocean. All roads lead to the same place. Beneath Pluto's frozen crust lies a vast liquid water ocean. We're not talking about some underground puddle. Scientists think this ocean could be over 100 kilometers deep, deeper than Earth's deepest trenches. It could hold a volume of water comparable to all of Earth's oceans combined. But how? How can liquid water exist on a world this cold and distant? The answer lies in clever physics in Pluto's interior. Deep inside is a rocky core, about 1,700 kilometers across. This core contains radioactive elements: uranium, thorium, potassium. As they decay, they release heat. Not much, but enough over billions of years. Above the core sits the ocean, liquid water mixed with ammonia and dissolved salts. The ammonia acts like antifreeze, dropping the freezing point from 0 degrees Celsius to potentially minus 100 degrees or lower. Above the ocean is a thick shell of water ice, maybe 200 kilometers thick. This ice acts like a perfect thermos, trapping heat from the radioactive core and keeping the ocean liquid. Recent research suggests an even more sophisticated setup. In 2019, scientists proposed a layer of gas hydrates, ice-like solids with trapped gas molecules, at the base of the ice shell. This would be an even better insulator, making it much easier to keep an ocean liquid over geological time. The implications are staggering. For decades, we thought the habitable zone around stars was narrow, just the right distance where liquid water could exist on a surface. Too close and water boils. Too far and it freezes. Pluto shows us habitable zones might be way larger than we thought. If a world has the right guts and chemistry, it can maintain liquid water almost anywhere in a solar system. The energy doesn't have to come from the star. It can come from within. This means dozens, maybe hundreds of ocean worlds in our solar system alone. Every large moon, every dwarf planet, every decent-sized asteroid could potentially harbor liquid water beneath its surface. We already found evidence for subsurface oceans on Europa, Enceladus, Ganymede, Callisto, and Titan. Pluto might just be the tip of the iceberg. But wait, there's more. Even as we've been solving Pluto's ocean mystery, new evidence keeps emerging. In 2021, astronomers made a startling discovery. Pluto's atmosphere is vanishing. As Pluto continues its 248-year orbit, it's moving farther from the sun. The surface is getting colder. The thin atmosphere is beginning to freeze out and fall as frost. Atmospheric pressure has dropped significantly since New Horizons flew by. New questions. What happens to the subsurface ocean during Pluto's winter? Does it freeze deeper? Does surface geology shut down? What will Pluto look like at the farthest point in its orbit, still over a century away? To answer these, we need to go back. Several mission concepts exist for a Pluto orbiter, a spacecraft that would spend years studying this world in detail. Such a mission could use radar to map the ocean directly, monitor the changing atmosphere, and search for active cryovolcanoes. One proposed mission, tentatively called Persephone, would arrive in the 2040s and orbit for years. It would carry ground-penetrating radar to measure ice shell thickness and confirm the ocean once and for all. Even without a return mission, New Horizons keeps delivering. After Pluto, it continued deeper into the Kuiper Belt. In 2019, it flew past Arrokoth, the most distant object ever explored. Arakoth looks like two pancakes stuck together, a contact binary formed when two objects gently merged. It's a pristine remnant from our solar system's formation, essentially unchanged for 4.5 billion years. By studying objects like Arakoth, we're learning about the building blocks that formed worlds like Pluto. Pluto teaches us something profound about our universe. For most of human history, we assumed life required a planet like Earth. Right distance from its star, right temperature, right atmosphere. But Pluto shows us the universe might be far more hospitable than we imagined. If a small, distant world like Pluto can maintain a vast ocean for billions of years, then ocean worlds might be incredibly common throughout the galaxy. Every star system might contain multiple worlds with subsurface seas. And where there's liquid water, there's potential for life. We don't know if anything lives in Pluto's hidden ocean. The water would be dark, cold, incredibly salty. But on Earth, we've found life thriving in similar conditions. Deep ocean trenches, underground caves, the most extreme environments imaginable. The search for life in our solar system no longer focuses just on Mars or Jupiter's moons. It's expanded to include worlds we once dismissed as dead and boring. Pluto taught us that small worlds can be just as complex and dynamic as large ones, maybe more so. So, what's the verdict? Pluto isn't just alive. It's one of the most geologically active and fascinating worlds in our entire solar system. What we thought was a cosmic reject turned out to be a masterclass in planetary science. The evidence is overwhelming. Beneath that heart-shaped plain, beneath those floating mountains, beneath that blue hazed atmosphere, lies an ocean comparable in volume to all of Earth's seas. A dark, alien sea that's existed since our solar system's dawn and might persist for billions of years more. But maybe the most important lesson from Pluto is this: the universe loves surprises. Every time we think we understand how planets work, how solar systems form, where life might exist, we discover something that changes everything. The case of Pluto is closed, but the investigation into ocean worlds just began. How many other boring worlds hide extraordinary secrets? What other assumptions about our solar system need overturning? What will we discover when we finally return to this distant, mysterious world at the edge of everything we know? The cosmos is vast, cold, and dark. But as Pluto showed us, it's also full of hidden wonders waiting to be discovered. Sometimes, the most incredible mysteries hide in places we least expect. Next time you look up at the night sky, remember, there's an ocean out there in the darkness, comparable in size to all Earth's seas combined, and we've only just begun to explore it.